So for this example, we have to find T1, T2, A1, A2. So for example, here, A1 is going down and A2 is going up. And we call this part T2, the tension is pulling it upwards. And also here, the tension is pulling it upwards, T1. Now, if we were to name this whole sector with all that's happening, we would call this mass of gravity 1, and we would call this mass of gravity 2. So this is kind of what we have working with right now, and we're just going to go ahead and say that the mass 1 is 8 kilograms, and that mass 2 is 5 kilograms. You can see one is heavier than the second one. So this equation is going to be force equals mass times acceleration, and a constant that we would know since there is no friction, it would be that T1 equals T2, and that the acceleration 1 would equal the negative acceleration 2. So these are just some constants that we are working with in this example. So we can just kind of like scoot back a little bit now, and let's just go ahead and start working on what our equations can be for this. So T1 is minus mg is equal to m1a1. That's basically this formula rewritten in terms of what we see here. But as we kind of like look and spy on it over here, we see that A1 is equal to negative A2. So we can go ahead and plug that in as well. But first, let's just go ahead and do. And now we're going to go ahead and write the same equation for T2. So T2 minus mg equals m2a2. Again, like I mentioned, that this A1 equals negative A2, so we want to make everything be in like terms. That's going to make our life easier. So the next step for this question is to put it in terms of T2. So also remember that T1 equals T2. So we're going to do T2 minus mg equals m1 minus a2. And the second equation is T2 minus mg equals m2a2. Now, so this next part is basically leave t on one side. So this is T2 equals mg minus m1 minus a2 sorry, not this minus, it's times. Sorry, minus m1, 2, and then that this T2 equals mg plus m2a2. Now, we know that these are both terms of T2, so they equal each other. mg minus m1a2 equals mg plus m2a2. Now, what we're going to try to do is combine like terms like with this stuff. All right, so we're going to go ahead and combine some like terms. So this next step is going to be to leave the A2 on one side. So here we would have negative m1a2, and we're going to bring this over, which is going to be minus m2a2, which equals negative m1g plus m2g. Now we can factor out. What would we be able to factor out? Na squared equals negative m1 minus m2 equals, here, g negative m1 plus m2. So that's what our equation is so far. So basically we want to leave a1 by itself, means we divide by negative m1 over m2, divide by negative m1 minus m2. So putting that in terms of the question, what that's going to be is a2 equals gravity, which is 9.8 kilometers per second squared, times what is our negative m1? That's going to be negative 8 plus 5 over negative 8 minus 5, which is going to equal 9.8 meters per second squared times negative 3 over negative 13, which when we show the work for that, the answer it's going to give us is 2.26 meters per second squared equals A2. We know that A1 is going to be the opposite of whatever A2 is. So if A1 is this, A2 is that, then A1 is going to be. Now, to do T equals M1G plus M1A1. That's kind of like the formula to find the T. So basically, what we can do is factor. So that means T equals M1 times G plus A1, which T is going to equal 8 kilograms times 9.8 meters per second squared plus negative 2.26 meters per second squared, which if we do the work for that, that is going to equal, remember it's doing this, that is going to equal 603 newtons. So putting all this work into perspective, I'm going to use another color. What we have, A1 equals negative 2.5 meters per second squared. A2 equals 2.5 meters per second squared. And T1 equals T2, which is 60.3 newtons or 60 newtons. And that's the answer.